All right, everybody, welcome back. So today's lesson is on static. This is one of the concepts in this class that I feel like can be a little bit tricky for people to understand. The actual use of static in real Java programs is not super common. I mean, there are some common uses for static methods, but particularly static fields other than constants are not particularly common. So in the sort of title sheet for the lesson, I show you kind of the most common use of static in actual Java code, and that's for two things. So first of all, probably what I should do is back up, talk a little bit about what static does. So the static keyword causes a variable or method that's declared as part of a class declaration to be available without an instance of the class. So in the past, if I wanted to call a method on a class, I needed to create an instance of the class first using new, and then I would be able to call that method. The instance method, which is the only kind that we've written up till this point, has access to the state of that instance. So as the method runs, it can access the values of the instance variables if you've declared an instance variables as part of your class, which we usually do. Static, so if I take a method or a variable and I mark it as static, what I'm doing is I'm allowing it to be used without an instance of the object. And so this gives you a couple of examples. And this is sort of, again, these examples are designed to hint at the appropriate use of static in our program. So to the degree that we use static at all, and I'm not saying that it's super common, but there are. Okay. Sorry about that. It looks like we're having some connectivity issues here today, which is frustrating. Not sure why this is happening, but I will try to forge onward. Hopefully we're reconnected now. So let's see. Back to the example. So you'll see here in both of these, so I've created a class and I've added one class variable. Sometimes that's what we refer to this now. So an instance variable is a variable that's declared without using the static keyword. Every instance has its own copy of that variable. A class variable, or one that I add the keyword static to, now becomes something that the class only has one copy of, but that I can also access without creating an instance. And so down here, you'll see that I'm using dot notation, but I'm also, I don't have an instance. Is there any instance that's being created here? Remember, if you don't see new, there's no instance of an object that's being created. And so down here at the bottom, there's nowhere in this code that I see the new keyword. And so nowhere in this code am I creating an object. And so nowhere in this code do I have an instance of anything. This snippet actually doesn't contain, it contains the class declaration, but it actually doesn't contain any objects because I've never created one using new. But despite that, because this variable pi, which I've declared as static, I can access it from by just using the name of the class, in this case, which is math, dot pi. And again, this is one of these places where these naming conventions comes in handy here in terms of understanding what's going on. So in Java, we typically name our variables with lowercase letters. We typically name our classes with uppercase letters. And so this is one of the times that you're going to see dot notation used on something that starts with a capital letter. I'll have the name of the class, dot pi. Now again, if I take off, so we'll talk a little bit about final in a minute, so don't let that freak you out too much. If I take this off, then I get a compiler error, because what the compiler is telling me is this is an instance variable, and to access it, you need an instance. The way that it explains this to you is a little confusing. It says non-static variable pi. What it means by that is instance variable pi cannot be referenced from a static context. What it means by that is you don't have an instance of the object. If I add static back, now I can print off this value. So that's one use, and we'll talk a little bit about final in a minute. That's another new piece of syntax that we're kind of slipping into this lesson just for fun. The other place that we see static used, and this is probably more common of the two sort of common uses of static, is to create what's sometimes known as a library method or a class method. So an instance method, we said we've been declaring up until this point. We would say public int, and again, I can play the same trick here. So if I remove static, then I get the same type of error from the compiler. It's complaining that the non-static method cannot be referenced from a static context. So the instance method POW requires an instance. So if I don't use the static keyword, I can't call this until I have an instance of the math class. I would have to use new to create a new math instance of math and then call the function. Now, as cool, Java's object system allows us to bring data and algorithms, state and behavior together into one place. And that's tremendously useful. But there are times when we don't need that capability. So for example, Java has a whole library. Actually, Java does have a class called math. And it has a whole library of math-related functions that are attached to a class called math. And all of those functions, I go through this in one of the videos as part of this lesson, all of those functions are static. And the reason is, so, one thing to think about with the static variable is that with the static method is that a static method has to receive all the information that it needs to run from its parameters. So when we started writing methods, remember before we introduced objects, we started writing methods, we were really writing static methods because we would pass all the information that the method needed to run to the method itself. Now that we started to be able to design our own objects, we see that there are times when it's appropriate to have the object, like with our tic-tac-toe game that we looked at last week, and we'll do this again at the end of this week. We see that there are times when it's appropriate for the object to contain state that it can use across multiple instance methods, which is pretty useful. However, there are still times when, like for this function, for example, I'm just doing some mathematics. So this is like a silly implementation of exponentiation with positive exponents, where I just use a loop in order to calculate an exponent. This function, if you think about it, receives all the information that it needs to run from its parameters. So I give it the base and I give it the exponent, and it does the right thing. This function doesn't need any instance state to operate. And so again, if I took off the static here, now it's complaining that I can't run it. So I could do something silly like math silly is equal to new math, and then I could call this on silly, and I would get the same result. But the point is, I shouldn't need to create an instance here. That instance isn't actually holding any state or serving any useful purpose. Instead, it's more useful to be able to mark this method as static so that I don't have to go through the trouble of creating this stupid, kind of useless object that's just there because I haven't figured out how to use static properly, basically. So these are the two primary uses of static that you'll see in actual real Java code in the wild. The other keyword that we're introducing here that's new is this keyword final. Final in Java can be applied to any variable, and it indicates that the variable cannot be modified. So after the variable is initialized, it cannot be set to a different value. So you can think of this variable as basically read only after the initial assignment, right? So there's one time that I'm allowed to modify its value, and that's during the assignment. If I try to modify this again later, I'm going to have a problem. So let's try to do that. Let's say math.py. Let's say I'm a joker and I want to mess up everybody's circle calculations. You'll see that Java, the compiler, enforces this constraint. The compiler knows that I've marked this variable as final, and so it won't allow me to assign a value to it after it's been initialized. Again, having a variable that I could never set a value to would be pretty useless, right? Because it would just be stuck at 0 or whatever the default value was. And so final allows you to modify the variable once as part of the assignment. Now again, if I do something like this, now it's going to complain because it's saying that this variable hasn't been initialized, and it knows that it's final, right? I could create a constructor to do this for the math class, but because this is the class that I'm using to hold static fields and methods. I don't want to write a constructor because no one's going to create one of these, and so I'll just initialize it this way, which is totally okay. So these are the primary two uses of static. Can static methods have no parameters? Yeah, they could. Let's write one. That's a great question. So I could do public static whatever. I'll say whatever. And let's gotta make this void because it doesn't return anything. Yeah, sure. Now I can say system. I just go math dot whatever. Yeah. Now, is it common to have a static method that doesn't accept any parameters? No, right? Because usually, remember, I have to pass all the information that I need to a static method through its parameters. Unlike instance methods, it can't read information off the instance. So, for example, let's think back to our tic-tac-toe example, right? So I think we had a function that basically determined if there was a winner, right? So that function that we wrote didn't take any parameters because it operated on the board that was part of the instance. That's where the state about the game was being saved. If I wanted to make it static, I would have to pass the board to it. If I don't pass the board to it, it's got no information if it's static, right? It can't read information off the instance because it's a static method, and I didn't pass any information through parameters. So what I suspect is that there probably are some no argument static methods. I doubt that there are many. Most of them, I think, probably take an argument. One thing that's worth pointing out, actually, that I didn't even think about until now, that I guess I could have explained as part of this lesson, but maybe I'll do it at some other time, is that now we're almost, not quite, but we're close to the point where you can understand what's going on here. So system.out.println. What is this? We've been typing this magic incantation in our code since we started learning Java, and it's never made a lot of sense. But really what this is a static method. It's a static method. It's part of a class called system. That's the name of this class right here. And there are other functions that I could call. So I could try to call, and I'm pretty sure would prevent you from doing this, system.exit. Oh, now it's mad about this. Okay, let's get rid of this. There we go. Yeah, so we don't let you do that. We don't let you do that. Normally, if you were running this on your own, system.exit would cause your program to exit and to stop running. And so if you could create your own program at the command line or in IntelliJ or whatever and call system.exit. And that's kind of like, it's almost like return from your entire program. It causes the entire program to stop running. We don't allow you to do this in our sandbox because we want our sandbox to keep running. And so we prevent you from exiting. But that's one, so you'll see now I'm seeing a pattern here. There's this system class that again is a class that has a series of static methods. And you can call these methods using dot notation. One of them is exit, which takes an int as a parameter. That's what's known as an exit code, and that's something you'll learn more about in the future. We don't allow you to call that function in the sandbox because, like I said, we want our sandbox backend to continue to run so that it can help other students. But system.out.println is a method that you can execute. Now, just to try to finish demystifying this slightly, you might wonder, well, why isn't it just system.println, right? Which you can't call. So anyway, this goes down a small rabbit hole, but when this goes actually back to the, this is a convention that, as far as I understand it, was established by very early computer systems. So, very early computer systems, you can imagine, like before there were graphical displays, had very limited ways to communicate with the user. They essentially had like it was almost like you were staring at, a terminal type display all day. So instead of like this nice, browser-based GUI or desktop environment or whatever, and I need to go and switch this over here, right? You would be staring at something like this all day long. And so when your programs ran and they needed to tell you something, the only real way they had to do that, they couldn't draw a picture, or they couldn't pop up a notification or whatever, all these cool things that we can do now with the much more sophisticated computer systems that we've created in the decades that have passed since then. Instead, they would just print something to this screen, right? And in order to make this slightly better, I guess, there are actually two different ways that your console can receive output. There's what's called standard output, which typically comes to the terminal and is printed in front of you when the program runs. And then there's also something called standard error. Standard error was a second, you can think of it as like a second channel that's designed for error messages, as you know it, as its name implies. So that's where this comes from. So actually, if we go back here, what you'll notice is that I can also do system.error.println math.py. From the perspective of the playground, there's no difference to you as the user here. You see the two printed in front of you. But this convention of having two different output streams, one that's for normal program output and the one that's for error program output, like when something goes wrong. And again, I don't know what original computer system created this approach, but this is why we have system.out.println, because we also have system.error.println. And so there's actually two ways to display something to the terminal. Now again, from the perspective of our playground, these two are completely indistinguishable from each other. On the homework problems, we do distinguish them. So for example, if we asked you to say print hello world to standard out using system.out.println and you do system.error.println, you would get the question wrong because we can differentiate between those two. But they look the same when they come back. Maybe I should change that. Maybe I should make one red or something just so you can tell the difference, but it doesn't matter. Anyway, but this is, so now we kind of know what's going on here. System, and again, I can look this up if you guys want. Let's see, Java system class, and we'll look up the latest version. And here it is. This is an actual class that's part of Java. It's called system. And most of the methods, let's see here, out, yeah, here we go. So it has this print stream called out, and then the, and that variable has a println method. So we're using system, which is this static, which is a class that has a bunch of static methods and fields on it. We're using system.out to get the output stream rather than the error stream, and then we're using println to print something to it. So that's what's happening. So you can see there are some other static methods here that we can accept. Current time millis, which looks, oh wait, sorry, I'm still on the wrong thing here. Okay. So sorry, back at system. So we're looking at the system class in Java, which is what we're using when we actually use system.out.println. And what I was pointing out is that there's a bunch of static methods here. So we were just trying to call exit, for example, which terminates the current running JVM. We can also do get, we can do current time millis. Let's see what that is going to do. So system dot, and I need to print this. So I'll do system dot get current time millis. And I must have spelled it wrong. Current time millis, sorry, not get. There it is. And you'll see every time I run that, you see that going up. That is the current time in milliseconds since 1970. I could go and convert this, right, from, so I'm going to convert this guy, and it's going to tell me that, yeah, see, I think I used, this is for seconds. So I need to chop off some zeros here. And now that's correct, right? That's 9:28, that's today. That's 4:27 p.m. UTC, but that time zone is 5 hours ahead of us. So this makes sense. There you go. So that's another method that we can call. And we'll actually use that method later in the class because we're going to do some experiments with algorithms where we actually get some timing information from the Java system. So anyway, so that's a little bit of a demystification of what's going on. So it's a question about what the order of the keywords is. Yeah, I can't remember. The thing that I remember is that check style will tell me if I'm wrong. So for example, if I try to do something like this, check style will complain. So check style is configured to do this for you. I think static, I think the visibility modifiers are always first. Followed by static. The type is always last. Those are the things I remember. So the visibility modifier, public, private, that goes all the way to the left. the type goes all the way to the right. On some level, if you think about it, those are the two most important pieces of information. What kind of variable this is. Sorry, the type and the name, obviously. The name is the last part of the left side of the assignment. So the type and the name are way over here. That's one really important piece of information. The visibility modifier is all the way on the left. That's another really important piece of information. The stuff that's in between, still important, has an impact on how the variable behaves, but not quite as critical. Hold on a second. Oh, that is Yeah, I think the JLS is the Java language specification, and I think it does have, and actually let's look this up. JLS modifier order, and we can see, let's see, here we go. Looks like check style has something about this, modifier order. Here we go. Yeah, so here's the, I'll blow this up a little bit so you can see it better. So here's the actual order according to the Java language specifications. So public, protected, private, those are first. And then, so these are modifiers. The type and the variable name are on the right. Static goes before final. And then there's some here that we're not gonna talk about. Like we'll probably talk about abstract for 10 minutes at some point. Transient, volatile, synchronized, native, strict FP. I think I know what most of these mean, but these are not things that you're going to use often. So this is the official order. And like I said, if you need help remembering what to do, just enable your project and it will provide useful reminders. So it's a great question. All right, so let me talk a little bit about this. That's the other thing, which is sort of a step backwards. So this has come up a little bit on the forum. So some people, for example, have been used to seeing something like this if they've programmed in Java before, right? You might have learned Java in high school and maybe your instructor taught you to do something like this. And so what's going on here? Well, in an instance method, and that includes a constructor, so any instance method or constructor, this refers to the current instance of the object that's running the method. So, and actually, let me go back and change this. So in this case, number and this dot number are exactly the same. If I just use number, Java will look it up on the class and change that particular object's instance variable. If I use this dot number, it does the same thing. And to the left I'm using this refers to the current class. So I don't have to use this when I set instance variables. And typically we try not to, just to kind of help you, first of all, because this isn't super common. And second of all, because, I think getting used to this type of notation makes it a little bit more clear what's happening here, right? And forces you to think about the fact that, this constructor can variable, because that instance variable is in scope in the constructor because it's part of that class. One of the things that you can do with this that, again, people have asked about is that, it seems sometimes like we would like to use the same names for the parameters to methods like constructors and setters that modify instance variables and the instance variables themselves. But then you have this awkward piece of code like this where at this point in the code, I have two number variables. I have one that's an instance variable and a second that's a parameter. So Java, a statement like this makes no sense, right? Because it's like, which number is on the right, which number is on the left? Are they the same one? I've got two variables with the same name that are both in scope at this point. Now what happens is that the parameter wins, right? So the parameter to this method causes, so when Java, and this is something that we'll go over probably on a walkthrough soon, just to sort of reinforce this. So when Java is trying to interpret this statement, it says, okay, what number are you talking about? The local variable. So for example, I could say int number is equal to 0. So now at this point, I'm sorry, let me no, I'll make it a number. Fine. So now at this point, I even have more confusion because I have 3 number variables that are in scope. I have a local variable named number, a parameter to my constructor named number, and an instance variable named number. And so this is a mess. Now what Java does is the first, when it starts looking, first it looks for local variables in the current scope, and then it kind of looks in the enclosed scope. So in this case, the first one it would find would be the int number. And now it's angry with me. And let me see if I make this a string, if it's actually going to be happier, right? No, see this one at least it's going to complain about. Unfortunately, this you can get away with, and I'm not exactly sure why Java allows you to do this, right? And what we've done is we've set up check style to help you avoid this problem. So check style is now going to produce an error here saying number hides a field. So what does that mean? What it means is that if Java is trying to figure out what this variable number is that you're talking about, it's always going to find this parameter to the method, and it's not going to find the instance variable. And so inside this method, because I've declared a parameter that hides or conflicts with the name of one of my instance variables for this class, I can't access the instance variable for that class by just using the word number. Now, if I wanted to fix this, I could use this. I could use dot notation in this. So this now makes it unambiguous. So this dot number is always going to refer to the instance variable called number that is available for an instance of this class. And number here will now refer to the parameter. So this statement would work if I turned off check style, but we don't allow you to do this. Now again, I could still use a different variable here, and I could do, and that would be fine. But at that point, you don't need this anymore. So that's one use for this, is when you've one of your parameters for your method has hidden one of your instance variables, and you need to get around that. But the right solution to that is to not use this. It's just to rename the parameter so that it doesn't cause a conflict. Because trust me, this will, not only is it less verbose, but it also will help you with other problems as well, right? If I have to think about the very fact that I have 2 variables called number, and one is the parameter and one is the instance variable, that's confusing. If I always use a convention when choosing the names of these variables. I always call them set name of the variable, right? And that helps me remember what that variable is trying to do, right? Okay. So the more common use, or the more important use for this, and I'll just sort of go through this here, is to do the following. So, and this is one use that you don't want to get away from. So let's say I had a constructor like this, and I'm not following my own advice. I'm going to say string number and int enrollment. And I'll make these private because I'm following best practices here about how to encapsulate the information that makes up my course object. And then I'm going to say number is equal to nombre, writing code in Spanish today, apparently. Enrollment is equal to set enrollment. Okay, so far I've got a very nice, according to the conventions that we've established. What if I want to write another constructor? So let's say I have a second constructor here, course string set number, and let's imagine that I want to be able to create a course and not initialize the enrollment, meaning that it should be set to 0. So one thing I could do here is I could just say number is equal to set number, and enrollment is equal to 0 because there's no parameter passed here for enrollment. This is fine, but imagine that my course object eventually has 2, 3, 4, 5, 6 different parameters. This is going to start to get unwieldy. And so what Java allows you to do is to call another constructor. Sometimes we refer to this as delegation. So I'm delegating construction of the object to another constructor. How do I do that? Well, it would be like, oh, I could use the name of the class and call it with different parameters, but that's not, I can't use new, well, I can use new inside a constructor, but it's not going to recall, it's going to create a new course method inside my constructor. It's not going to affect the creation of the current instance of the course method that I'm involved in creating at that point. So the way I do this is by using the keyword this. And so this is how I would do this. I'm essentially going to delegate to this constructor. And if we experiment with this down here, we can say new course, and let's say this one I'm going to set all the fields, and then I'll say creating a second course, and I'm going to call this just pass 1, right? So that's fine. And now I don't have a getter for my enrollment, so let's create one just so that we can actually see the same convention. Now we'll say second.get enrollment, and that's 0, right? And I could use the convention that the enrollment is -1 if it's not set or whatever. And so this is one place where you do see the this keyword used directly, is when I need to delegate to another constructor. And that's pretty common. Again, this is a place where I would argue Java's syntax is not particularly fantastic, shall we say, for this type of stuff, right? In the sense that, if you've used languages like Python, that Python allows you to provide defaults. So I don't have to write like 8 different constructors for the same object. So a lot of times for a particular object, you do want a lot of default values. And so you end up having to write, if your object has 8 fields, you might have one complete constructor that sets all the fields. And then you might have one constructor that sets a subset, another constructor that sets another subset. And it gets really tedious and awkward about Java, right, is the fact that it requires you to do this. Maybe they'll fix that someday. I don't know. I'm not holding my breath. But that's what you have to do right now. That's today's lesson. It's on static. It's, one of those things that, we're going to see, right? I mean, at this point in the class, over the next week or so, I'm showing you things because you'll see them in the wild. You might need to use them from time to time, just sort of things that are out of code in the real world. And because they solve certain problems, they'll be able to do. So that's our goal. All right, I am available for more questions, and I would love to take some. So if you guys go ahead, I'll hang out here for a few minutes, awaiting any questions, and then we can, if not, I'll take off. There's one last piece here that I'm not even going to go over, which is this use of static to create modifiable class fields or static fields. This is one of those things that is so open to misunderstanding and mistake that I am downplaying it this year. So I do have a walkthrough that you're welcome to enjoy as part of the lesson. I am not going to cover this in depth because it is a source of just something that I've seen people make a lot of mistakes with in the past. And it's also one of those things that's not important enough to really worry about too much because you're not probably going to need this. There might be some day in the future where like you discover that you need a modifiable static field, so a non-final static field, something that's not a constant, something that can actually be changed as the code runs. And at that point you may discover that this is possible and be able to use this, but in the meantime, it's not something that I think is worth teaching because it's dangerous. And I've just seen people make too many mistakes with this, and I think it's tough to understand. So, all right, floor is open for questions, and I'll be here for a few more minutes. All right, it seems like we're out of questions today, so I hope you guys are doing well, and